Alright, so there's an ongoing debate whether Earth is spinning or the stars are spinning around Earth. Now, I am not talking about a flat Earth argument. This is a globe Earth, and it's commonly said that Tycho thought that although Earth was a globe, that it did not spin. However, he never states that in his book. And if he does, please send me the page number, because his model in and of itself refutes the very idea. So let's take a look at it. Here's the moon. Now this is going to be the next full moon in this month on the 30th. This is May 2026. You see the moon is up. This is going to be a very good time to watch this, because look how close the moon is to the bright star Antares. Antares is the heart of the Scorpion, malefic star. And let's take a look at the right ascension for Antares here. And we see 16 hours 29 minutes. Now let's take a look at the moon, and we've got 16 hours 15 minutes. And what we're looking at here is the right ascension, and we can see the grid up here. So we and Terry's right up there at the top, and you can see it's right on that might be hard to see, 16 hours and 30 minutes, that grid line, and the moon is on 16 hours and 15 minutes, that grid line. See, it's right, they're every 5 minutes, and they're going uh, from left to right descending, and from right to left ascending. So we've got Antares 16 hours, 29 minutes, 25 seconds. We've got the moon 16 hours, 15 minutes. Now let's zoom out and let's just speed it up and watch the two move across the night sky from left to right, as we'll see. Now, bear in mind, in this case, we're going to contend Earth is not spinning. So the only motion that we are going to observe will be the motion of the sky. And I'll take that grid off to make it a little more obvious. So here we go. Not a spinning Earth, simply the sky spinning. Here we go. Speed it up. And if you ever go outside at night, this is pretty much what you will see. I realize that most of the people making comments on the solar system never actually go outside at night and watch the sky. So there you can see it's about to set. The moon and Antares together cross the night sky. And the moon now has a right ascension of 16 hours, 28 minutes. So what is the right ascension of Antares going to now be? Any guesses? The right ascension of Antares is exactly the same as when it began, because Antares is a fixed star. It does not move relative to the ecliptic. It stays put. So it's 16 hours 29 minutes when it started, 16 hours and 29 minutes when it set. So why did the moon that moved with Antares throughout the night end up with a nearly 15-minute divergence between its original position and its ending position. Because if Earth is not spinning, then these two things have to be moving along together. Now, in the case of the moon, remember what I said, we go from right to left with increasing right ascension, as we can see up there. As we can see, the moon's right ascension started out, let's roll it back. We can see the moon's beginning right ascension was 16 hours, 16 minutes. However, it ended at 16 hours, 28 minutes. So this indicates its direction. Now let's isolate its direction and find out why it appears to be moving from right to left. Now I'm going to get rid of Earth altogether. I'm going to put the view on equatorial so that the moon will stay centered, or our point of view will stay centered on the moon. And I'm going to speed that up. And here we go. As we can see, the moon is moving right to left. And why does that make sense? Let's show the moon moving. Its right ascension will increase as we go forward in time. So let's just speed this up a little. And we can see it's 15 hours, 29 minutes, 15 hours, 30 minutes, 15 hours, 31 minutes. Let's speed it up a little bit more. And we can actually see the moon moving right to left. And that makes sense because we noticed that its right ascension had increased during the night. There's no way to explain this because you have two reference frames here. So we see the moon clearly is moving in the opposite direction. How can it also at the same time be moving left to right or east to west? It can't be doing both at the same time. They're mutually exclusive. So that means you have to incorporate a second motion, a second frame of reference. That's the Earth's spin. Moon's just over the horizon. Let's speed it up. Let's show that east to west, left to right motion caused by Earth's spin. And there you see it. That's the spin of the Earth. Because we already know the moon is moving toward Antares, and you can actually see the gap decreasing. That's because the moon is a fast mover. It's very close to us. It moves about 13 degrees per day. Since it's so close and so fast, it laps everything else, like the sun. It laps the sun. And that's why you have the different phases. Both of these motions can't be happening at the same time, just simply due to the motion of one body, because either the moon's got to be going that direction or either the moon has to be going the other direction. And maybe you could say stellarium's wrong. Well, if you think it's wrong, then just go outside and check its coordinates because they're they're dead on. We'll put the equatorial mount on. That keeps our position centered so we're not spinning around. It's like having a telescope focused at one point in the sky that compensates for the Earth's spin, and that's another reason why of course, we have a spinning Earth. Star Tracker wouldn't work